Okay, welcome back. Last section in chapter 1. We've got this taken care of. We're going to talk about introduction to parent functions. What we want to be able to do is identify these parent functions. These are common functions that we see either from a graph or an equation. And it's really the simplest version of the type of graph or function that we can have. When you see a constant, it's just going to be like f of x or y equals a number. It's going to be a horizontal line. All right, and then linear, you're going to see it just with an x. Now we could, as we talked about transformations, we could go +4, -3, multiplied by half, and that's going to change the line a little bit, but it's still going to look like a line. And sometimes it can slope downward too. And then we have our quadratics, which are parabola-shaped, U-shaped graphs. We call that parabola. It could be a smiley face or a frowny face, but the key thing there is that the equation has the x squared. And then the cubic is my favorite. It's cubed, x cubed. And the type of graph, I always call this the "oh no you didn't" girlfriend graph. Yeah, a little bit of attitude there, that's good. My favorite graph. And then we have the square root graph that kind of looks a little bit like that. So what we want you to be able to do is if we give you an equation of some sort, you should be able to pick out which one it is. Use this as a reference. Or if we give you a graph, we want you to be able to look at that. Now again, we have graphing calculators. We can always type it into the calculator and graph it if we want to kind of visualize what goes on. Okay. All right, so let's take a look here. We have this one here. All right, x minus 3, this is the equation. Now we know it just has an x, and then we can graph it. Well, obviously that's going to be linear. And apparently it looks as if from the original that -3 has moved it down 3. And we're going to look at those rules later on, but you can kind of get a little taste of what's happening. All right, how about this one, x squared? Now this looks like it's the parabola quadratic, right? Well, what does the +5 look like? Well, it looks like it moved it up 5 from our original graph that we had before. Yeah. All right. And then let's see, what about this one? Oh yeah, x cubed plus 2. I know since it's cubed, got to be cubic. There's our graph. Oh no, you didn't. Plus 2 looks as if it moved it up 2. So that's the transformation. So we want to identify that parent function that we have. Okay, now sometimes we're not given an equation or a graph, but we're given some data points. Now what we'd want to be able to do then is plot these on a graph and then try to see which one does it look the closest to. Okay, what's the behavior? What are we thinking? All right, so as we look at something like this, well, if we plot those points, like I got the graph over there, well, clearly that looks like it's a quadratic. I think that's pretty easy to kind of say what's happened there. If we do another one like this, if we graph this set of data points, well, obviously this one looks like it's linear. All right, and so you want to be able to describe what those are. Just plot those points. Make sure you scale your graphs. If you're just making them, just plot them out and see what they look like. Now, when you do that, make sure that you have more than 2 points, and here's a good reason why. If you plotted the 2 data points, 0, 0, and 0, 1, those are data points for all 4 of those graphs. You would not know which one it is. So it's obviously the more points you use, the better the graph's going to look. Typically, at least 3, probably 4 or 5. The more you use, the better it's going to be to describe those, okay? So make sure you talk about constants, linear, quadratic, cubic, square roots. Get to know those by equation and by graph, and that's it for Chapter 1, and 1.9 and Chapter 1. All right, so there we go. First chapter under our belt. We'll start Chapter 2 next. Until next time, I'm Mr. Boone.